מעולה. אז צהריים טובים לכולם, אנחנו מתחילים. כאמור, פתיחה בעברית ואחר כך סשן של טוסטן יהיה באנגלית. לאלה שמגיעים לפה כל פעם, אז אתם מכירים את הנוהל, קצת לינקים, אירועים וכאלה, מי שחדש אז זה הזדמנות להכיר אותנו, ותוך כדי גם העדכונים חדשים אולי. אז אנחנו נמצאים במיטאפ, נקראים את הפלטפורם מיטאפ, יש פה את הלינק וגם את ה-QR קוד, וגם כרגיל אני שם לכם את כל הלינקים בצ'אט, אז מי שלא שם עדיין מוזמן להירשם ולהכיר את כל המיטאפים הקרובים שיש לנו כבר, ויש כמה, תכף נדבר עליהם. אז הנה שמתי לכם לינק להירשם לשם. יש לנו קבוצה מאוד פעילה בפייסבוק, הרבה מאוד אנשים, דיונים מקצועיים, אנשים שחפשים עבודה, מחפשים עובדים וכולי וכולי וכולי. אז אם אתם לא שם, אז הנה הלינק להצטרף לשם, להיות חלק מהקהילה, להיות בעניינים. ערוץ היוטיוב שלנו, כל הסשנים האלה שאנחנו עושים פה מוקלטים ועולים לשם, יש שם כבר ארכיון מאוד מאוד עשיר, אז אתם מוזמנים להירשם ולקבל עדכונים כל פעם שעולה משהו חדש, למשל היום אחרי הרצאה, אחרי שנסיים אותה, אני אעלה את זה לשם, ואז תקבלו הודעה שיש משהו חדש, אפשר לצפות בכל הארכיון. והפודקאסט שלנו SQL Server Radio, שלי ושל איתן, כל מה שקשור ל-SQL Server, הכל, פיצ'רים, פרויקטים, מרואיינים באולפן וכולי וכולי. אז מי שרוצה לעקוב בפורמט של פודקאסט, מוזמן, יש גם גרסה באנגלית, שזה .com בסוף, אז הנה הלינק גם לזה. קבוצת הטלגרם שלנו, המומחים של מדרה, יש שם הרבה יותר מומחים של מדרה, יש שם 200 ומשהו אנשים, זה המקום לאינסטנט, יש לכם שאלה מקצועית בתחום של דאטה פלטפורם של מייקרוסופט, מוזמנים לעלות אותה שמה, די מהר אתם תקבלו תשובה מהרבה מאוד אנשים, אז אם נתקעתם ואתם עכשיו לא יודעים את התשובה למשהו, אז זה המקום לשאול, זה בטלגרם. והלינק האחרון בהקשר הזה זה מדרה טולבוקס, רפוזיטורי שלנו בגיטהאב, שאליו אנחנו מעלים את כל מה שאנחנו מפתחים, סקריפטים שימושיים, כלים כאלה ואחרים, שהם כולם אופן סורס, מוזמנים להסתובב שם, למצוא דברים מעניינים, להוריד, להשתמש. הנה הלינק גם לזה. זה של הקבוצה בטלגרם, כן, הלינק הזה של טלגרם, חצו על זה, תצטרפו לקבוצה. זהו, זה בקשר ללינקים האלה. משהו קטן, לאחרונה מייקרוסופט הוציא הרבה מאוד טריינינגס, אונליין קורסים בעצם, שקוראים ברמה שבועית, על פאוור BI, למתחילים, כל מי שרוצה ללמוד פאוור BI, תיכנסו פה לאתר הזה, אני גם שם לכם את הלינק הזה, גם כן בצ'אט עוד רגע, אז כל מי שבעניין של פאוור BI, מומלץ, יש שם הרבה מאוד קורסים, שיעורים, חיים, בחינם, אפשר להירשם ולהצטרף, גם ללמוד מהם וגם זה אינטראקטיבי, אפשר לשאול שאלות את הצוות של מייקרוסופט וכולי, אז כדאי שתכירו גם את זה, גם זה כרגע בצ'אט. אני תמיד שואל, ואף אחד לא עונה בדרך כלל, אז חוץ ממני, אז אני גם אגיד, אבל אני בכל זאת שואל, אם יש אנשים שמחפשים עבודה, או שמחפשים עובדים בתחום הזה של דאטה, אז זה הבמה, זה המקום, אנחנו קהילה ומנסים לעזור אחד לשני, אם מישהו רוצה לפתוח מיקרופון ולהציג את עצמו, כזה או כזה, אז מוזמן, ניתן לכם 3 שניות. עברו 3 שניות, זה בנוהל, אנחנו עושים נוהל כזה. אז חלק מהנוהל זה שאני אגיד לכם שאנחנו במדרה מחפשים, יש לנו הרבה מאוד הזדמנויות, המון פרויקטים מאוד מעניינים בתחום של הדאטה פלטפורם של מייקרוסופט, בעיקר באז'ור, גם סביב אז'ור SQL, אבל גם אז'ור Data Engineers, אם זה תהליכי ETL או ELT, Data Factory, Synapse Analytics, Cosmos DB, Data Explorer, Power BI, הכל מהכל. אז מי שבעולמות האלה, גם מי שמכיר רק חלק ורוצה ללמוד, ויש לו מה שנקרא פוטנציאל, ויכול ללמוד מהר, אנחנו נשמח, אנחנו מחפשים, אז דברו איתי, תמצאו אותי בכל הערוצים. זה בהקשר הזה. בפעם שעברה, זה היה בסוף יוני, הייתה הרצאה של מתן מטבולה על Data Engineers, אפרופו מה שאמרתי קודם, איך נראית העבודה של Data Engineers אצלם בצוות בטבולה. לבקשת טבולה הורדנו את ההקלטה של ההרצאה מיוטיוב, יש להם שם איזשהו עניין שהם רצו לבדוק, לוודא וזה, אז קיבלנו את הבקשה שלהם, אז כל מי ששאל אותי מה קרה להרצאה, למה היא נעלמה, אז זאת הסיבה, אני מקווה שבקרוב הם יגידו לי הכל בסדר ויאשרו את זה לעלות החזרה, אבל בינתיים זה מופיע שם כפרייבט, אז אי אפשר לגשת להקלטה, אז שתדעו מה הסיבה. מה מחכה לנו בהמשך? יש לנו החודש ביולי, חוץ מהיום, שתכף נדבר על זה, אז יש לנו בעצם עוד 2 מפגשים, 3 מפגשים סך הכל, שהפעם כולם באנגלית, יולי אנחנו בסימן בינלאומי, 3 מרצים גדולים מהעולם, היום תורסטן סטראוס, שתכף אני אציג אותו, ויש לנו ב-21 ליולי את ניקו נויגבאואר, מהצוות של מייקרוסופט של SQL Managed Instance, ידבר, כמו שאתם רואים פה, על כמה סיבות טובות למה כדאי לכם להשתמש באז'ור SQL Managed Instance. זה יקרה ב-21 ביולי, ב-29 ביולי, עמית בנסל, עוד דאטה פלטפורם MVP מהודו, מנהל קבוצה של דאטה פלטפורם גיקס, למי שמכיר, מוכר ומפורסם, עושה הרבה מאוד הרצאות וסשנים כאלה ואחרים, הולך להעביר לנו סשן, גם באנגלית כמובן, כמו שאתם רואים, על כל מיני טכניקות, איך לשפר ביצועים ב-SQL Server. אז מי שבתחום הזה של Performance Tuning של SQL Server, אז קודם כל טוב שבאתם היום, כי זה גם מאוד רלוונטי, ותעבור גם ב-29 ביולי. אז זה מבחינת דברים שיש לנו בקרוב. מזכיר לכם שיש לנו Call for Speakers, יש אתר ב-Sessionize, כל מי שרוצה להציע את עצמו, וזה יכול להיות כל נושא, כמובן כל נושא שקשור לעולמות של דאטה, כן? יש המון, אז כל נושא חדש שלמדתם ושאתם רוצים להעביר ידע לאחרים, או נושא שאתם כבר בקיאים בו, מכירים אותו מצוין ורוצים ללמד אחרים, או איזשהו פרויקט מעניין, משהו שאתם פיתחתם, משהו שעשיתם ואתם רוצים לשתף, זה יכול להיות כל דבר, לכל אחד מהאנשים פה ובקהילה שלנו בכלל יש המון ידע לשתף עם הקהילה, וזה המטרה, ללמוד אחד מהשני. אז אני מזמין אתכם לעלות לשם, אתם רוצים להתייעץ איתי בכיף, בשמחה, דברו איתי קודם, תתייעצו איתי, כן מתאים, לא מתאים, מה כדאי, איך לכתוב אבסטרקט וכולי, אני אשמח לעזור במה שאני יכול, אבל זה, אז תעלו את זה לשם. זהו, I'll switch to English now. It's time to introduce Thorsten Strauss, Data Platform MVP and Senior Consultant in the field of Microsoft Data Platform. He's going to talk about weight statistics, which is a very important topic when it comes to troubleshooting and performance tuning in SQL Server. And I think that's it. Thorsten, it's all yours.
Yeah, great. So can you hear me?
Yeah.
Perfect. So I will take over. So I will share my screen. So hopefully you can see my screen.
Yes, we can.
Okay, perfect. So yeah, that's me. So you already introduced me. So my name is Thorsten Strauss. I'm a consultant, trainer, and speaker. Microsoft Most Valuable Professional for Data Platform since a while, and focusing on SQL Server performance optimization.
Thorsten, there is a bit of echo now. Can you do something about it?
I cannot. I don't. Let me try something. Maybe I need to reduce my microphones. Is this better now?
I'm not sure.
1 second. Let me do. Is this better now?
Yes.
Okay. Okay, great. So yeah, introduction is done, I guess. So we can start. Yeah, let me just close the PowerPoint presentation. Okay. So yes, as you already mentioned, so weight statistics is definitely one of the most important topic you need to understand whenever you want to troubleshoot performance issues on SQL Server, or even understand that you have performance issues on your SQL Server, because without knowing what is going on, you do not have any idea where to tune. So it is not the query. So the query you're going to tune is really the last piece of the overall puzzle. Yeah. So most people start with I would say query tuning, but overall I would say it is much more important to concentrate on everything else, because a query can run slow, and the next time the same query can run much faster, because maybe the query was waiting for an incompatible log, which is a blocking situation. So the culprit of the query or the culprit of the performance issue is not the query which is currently running. It is another query which prevents the current query to be executed, right? So therefore you need to understand what is your problem, and the problem, and SQL Server will tell you what the problem is. And all these kind of issues, all these kind of problems you can see with when you understand weight statistics. So what I will do is I will switch over to, I don't know who created this chart. I have no clue, but this is definitely worth to understand. So whenever you ask SQL Server to execute a query, you can see you ask for a task. So a task is nothing else than a description of with a description for SQL Server, what SQL Server should do in order to satisfy the query, right? This is a task. So this is just a logical component. This is not a physical component, right? It's just the description. Okay, so the next SQL Server is trying to do, so there is a specific number of worker threads in the so-called thread pool. There's a formula behind which highly depends on CPU. So the more CPU you have, the better, or the more worker threads you will have. But nevertheless, if there's an idle worker, SQL Server take an idle worker and allocate a task to the worker, right? So once the task is tied to worker, the worker will never ever release the task until the task and the work is done, okay? So once the worker thread is taken from SQL Server, you can see that the query execution starts. So we have parsing, we have compilation, we have optimization, and so forth. And in the end, we have a query execution, which means, you can see the result you're hopefully asking for. So, and once the overall query execution is done, only then the worker or the thread will release, or the task, no, the other way around. The thread will release the task, so it becomes idle again. So there's another picture which you need to understand, and this is also a very important picture. You can see this is the so-called scheduler. So we have a running task or running state. We have something which is a wait for resources, and we have a runnable queue. So that means a thread can have 3 different states. We always start with waiting for resources, which is a so-called suspended queue. It is a queue, right? So the more threads you have in the queue, the longer the thread have to wait. And here it waits for resources, which means the thread will wait for CPU, it will wait for memory, it will wait for disk, it will wait for an incompatible lock or whatever. So there are more than 900, or I think in 2019, even more than 1,000 different reasons that a thread can wait in the suspended queue. And when the thread is waiting, the execution cannot be started, right? So the query is executed, but the actual work is not done yet. It is not even started yet, okay? So this is a so-called unordered queue.
Thorsten?
Yeah?
Can you hear me? I'm sorry to stop you again, but there is a background noise. Someone else is speaking. I think it comes from you.
It comes from me. Okay, then give me 1 minute, because if we really have these kind of issues, I will move to a quiet place. Can you give me 1 minute? So
yeah, sure. Thanks.
Okay, perfect.
Thank you. אז לשאלה שלך, יזהר, זה לא אני.
Okay, I hope this is better.
Yeah.
Yeah, okay, perfect.
Okay,
So,
great. Thanks.
for me, no worries. For me, it was not that loud, but okay, for sure, you need to understand what I'm talking about. So great. So just to repeat, so whenever the task is tied to a thread, the thread will wait in a suspended queue, which is the wait for resources. And then again, we have more than 900 different reasons that a thread can wait. So once a thread has a resource, it will go to the so-called runnable queue. The runnable queue is an ordered queue. The thread has, again, to wait until it will be picked up by the so-called CPU, which is a running state. The only way to influence the order of the queue in runnable queue is to configure the resource governor. Maybe you know about the resource governor. The resource governor is something which is an enterprise feature. And with the enterprise feature, the resource governor, you can prioritize specific threads within the scheduler. Okay, so once the thread is picked up from the CPU and it is in the running state, it will be there for exactly a quantum. A quantum is 4 milliseconds. And within 4 milliseconds, the CPU is trying to do the work the task is, or the thread is looking for. So when the 4 milliseconds, the quantum is over, the thread will, is forced to leave the CPU, the running state, and again will go to the runnable queue. So that means we have a shortcut from the running to the runnable queue, and this kind of, I would say, is some kind of life cycle of the thread. This is called SOS scheduler yield. So whenever the thread cannot finish the work within 4 milliseconds, then it will go to the runnable queue again, will go to the running through the CPU again, and back to the runnable queue. So again, this is something like a life cycle of the thread. And the more often the thread is going from the running into the runnable queue, the higher the so-called SOS scheduler yield is. So that means every SOS scheduler yield also causes so-called context switch. That means the CPU, all these kind of information which are currently in this in the cache of the CPU, is released, and the new thread, which is currently on the CPU, will load all the instructions into the CPU to do the work. So that means when you have a high number of SOS scheduler yield, this can already identify that you have a CPU issue. Because again, when you have a very slow CPU, then for sure the work a CPU can do within a quantum, within a 4 millisecond, is much less than when you have a very fast CPU, where a lot of instructions can be done at the same time. So that means whenever you look into your wait stats, and we will see how the wait stats work, and you can see SOS scheduler yield, the top 10 list of, I would say, wait stats. Yeah, this can already be a signal that your CPU is too slow. On the other hand, if you are able to reduce the instructions and make queries less complex, then for sure, SOS scheduler yield can also be reduced, because if the query is not that complex, the CPU can, I would say, can do or have to work less on the same task comparing to a much more complex query. Yeah, so this is something you have to consider. So let's go to Management Studio. Why does it not work? So let's go to Management Studio and try to understand how a query or a user interact with SQL Server. First of all, as mentioned, we have a connection. So a connection is nothing else than a physical communication channel between SQL Server and the application. That means a connection can have 0, 1, or more than one session. So whenever you start Management Studio and you open a new session, you have a new connection in place, right? But there are several ways to allocate one connection to more than one session. So we can use DMExec connections, for example, in order to get the current number and current idea about why it is already switching back to, let me close this one. I don't know what is working. Whenever I press the mouse button, this happens. Strange. Okay, interesting. Let me close. My mouse is not working anymore. Ah, great. 1 second. Sorry for the technical issues I have, but this is something which I cannot foresee. I'm just trying to switch to the other application. Okay, now it works. Yeah, okay, it works. Good. Okay, so this is what I get when I execute this DMExec connections and do an auto apply through this DMExec SQL text. So we can see the connections which are currently, the connections which are currently open. So we have 5 connections, and we have 1 session allocated to each connection, as you can see. So we can see the connection time. This is sometimes very important to understand how long the connection is open, and also the, I would say the protocol. So currently I'm using my local machine, which is shared memory, and we have something like name pipes and TCP/IP. So a lot of information are already included in this DMV. So we can for sure enable, or not enable, but configure the maximum number of user connections. Currently it is set to, you can see it, 32,767, which is the maximum allowed number of user connections. Yeah, there is a reason for it, because every connection allocates memory, which is 3 times the network package size plus 94 kilobytes. That means the more connections you have, the more memory you already allocate just by establishing a new connection. So that is a reason why Microsoft or SQL Server prevent or set a maximum user connections. For sure you can, if you like, you can extend the maximum, but normally, again, take into consideration that every new connection allocates memory. So this can be a problem whenever you have to work with a, I don't know, with a web interface or whatever, with a website, where you have to deal with a lot of connections. And the reason, or there is one idea in order to prevent that you are allocating more and more memory, the more connections you establish. And this is called connection pooling. So connection pooling means that whenever the first connection is established to SQL Server and the query is executed, the connection will be closed, but the connection itself will remain in a so-called connection pool. So that means the next connection will get the connection from the connection pool instead of, I would say, really establish the overall connection process to SQL Server, which is handshake. Then we have the protocol. We have a lot of overhead by just establishing a connection. And again, when you have a specific number of connections in the connection pool, this is first of all much faster, and you can save a lot of memory, because once the connection is released, it is still in the connection pool. It is still active, and another connection can get the connection from the pool. So whenever you work with an ADO connection, for example, so ADO connection string to be precise, connection pooling is on by default. When you work with an ODBC connection string, connection pooling is off by default. But you can for sure add something which is connection pooling property to your ODBC connection to allow SQL Server to benefit from connection pooling, which is definitely worth to do. Yeah. Okay, so let me go down. So sometimes you wonder whether connections are pooled or not, and therefore you can run an extended event session. So what you can do is you can easily create an extended event session, and the only event you're looking for is SQL Server login. So I can start the event session which I created. Let me go to management and extended events, session connection pooling, and just watch live data. Okay, so when I now I would establish a new connection by just establishing a new session, so we can see that we have that the extended event captures this event. That means it reacts on the connection we establish with SQL Server by SSMS. And there's one property which is called isCached. So when it is set to false, that means there is no connection pooling in place, which is currently the case in my environment. But you can also see isCached false. That means the new connections will use connection pooling, as you can see here. Yeah? So isCached is set to true. So again, this is something you should consider whenever you work with an web interface or whatever. Yeah? So connection pooling is definitely worth to set. Let me stop this one. Okay, we'll do some housekeeping. Perfect. So we are still here in this, I would say, in the chart. So once we have the connection in place, again, it will allocate a session before it will allocate a task. Yeah? So we have the session, we have the connection, then we have the session, then we have the task. So again, the session is nothing else than a so-called semi-permanent container, which is just, I would say, a description of all the details which is specific to this session. You know that we can have specific session open and we can define specific session properties like date first or whatever. So we have a lot of properties which we can set for this specific session within this connection. There is one DMV which we can use, which is called DMExec sessions, which we can easily link to DMExec connections. And with this information, we can already see a lot of very useful information once it comes to troubleshooting. So again, we have all the information from the connection. And in the end, we can see a lot of information with regards to the session. Yeah? So when you go through all the information, you will see a lot of very helpful details. Yeah? Okay, so now we have the connection, we have the session, and then what we are actually doing is we request SQL Server to do something. So before the task, we have a request. This is just the, this is what we want to be executed from SQL Server. This is a request. Yeah, this is a logical description of the work. So, for example, when I execute this statement here, this is currently running in session 55, and I just need to make sure that I have the right session here in place. I can get a lot of information about the connection, the session, and for sure the request. In the end, we can see a lot of information about the request. For example, what is the actual request, which is nothing else than the SQL statement which is currently running. We can also get the execution plan. Again, the execution plan is something SQL Server have to create before the execution can start, right? Because otherwise SQL Server does not know how to execute the query. So this is, I would say, a logical description about how SQL Server has to execute this query, which is currently running. So we will have a lot of information with regards to the request. So once we have the request in place, we get a task. Yeah? And a task can be one task for one request, or there can be more than one task for the same request. Think about parallelism. So let me demonstrate this one. So I will execute this statement another time, and I will open a new session for it. We are just, it's almost the same query, but we hint the query so that SQL Server can use 4 CPUs at maximum. So currently I have a laptop in front of me which have 8 cores. So, but we will limit the query to 4 cores. When I now execute the query, I just need to ensure that I have the right split in place. Execute. Oh, I need to execute this one. And when it is running, I can see a lot of information here. So you can still see the connection, we can still see the session, we can still see the request, and in the end, we get information about the task. You can see the task here. We have 4 records for one request. So why do we have more than one task for the same request? When we look into the execution plan, and this is something which we can see here, so we have a parallel execution of the query. So whenever we have this kind of double arrow, this is a signal for parallelism. So that means the overall request, so the SQL statement, results in 5 tasks. So why 5? Because whenever SQL Server have to execute queries in parallel, and we limit the number of CPUs to 4 with max.4 in our example, SQL Server also have to introduce a so-called coordinator thread, thread 0, right? So that means when we run a query with 4 or 8 or I don't know 16 threads, we always have one additional coordinator thread. So that is the reason why we can see 5 records which belong to the same requests. And all the tasks belong to the same request and are doing work completely independently from all the other 4 tasks. Yeah? So this is something you have to understand. The other thing you have to understand is that the task itself, again, can have different states. And all the states you know already. This is suspended, running, and runnable. So all the threads, all the tasks within the request are now going through the life cycle of the task, respectively life cycle of the thread. So we have suspended, we have running, we have runnable. Okay, so this is about the task. The next thing is, or the next, I would say it is a logical construct within SQL Server, which is called a scheduler. So in former times, SQL Server, I think it is 20 years ago or whatever, but at least in 20 years ago, SQL Server was a so-called preemptive operational system. That means SQL Server completely relies on the host, which is Windows. So, and Windows have to manage all the requests and all the threads. The problem here is, think about an antivirus scanner on your Windows machine. So Windows will execute the antivirus scanner with a very high priority. And you know that the virus scanner will allocate a lot of CPU. And for sure will also allocate, I don't know, a few threads. That means the CPU is busy with the antivirus scanner. That means when you now execute a query in SQL Server, you compete with the existing threads which are currently managed by Windows. And the antivirus scanner, for example, always have a higher priority than SQL Server. That means your queries have to wait. And you cannot predict how long it takes, because sometimes the antivirus scanner is running, sometimes the antivirus scanner is not active. That means sometimes your query is running very fast and sometimes your query waits for. So that is the reason why Microsoft decided to implement a complete separate engine, a complete separate operational system, which is a non-preemptive system. That means SQL Server has will manage all the threads within a logical scheduler, and Windows cannot, in any case, force SQL Server to execute threads for less than 4 milliseconds or even longer than 4 milliseconds. So this is completely separated from each other. So why do we have a quantum? So again, a quantum is just 4 milliseconds, nothing else. The way I think in 2005 it was 8 milliseconds. Yeah, I didn't believe, but a colleague of mine really showed me that the quantum was defined at 8 milliseconds. So, but since then, the quantum is 4 milliseconds. So the reason why Microsoft decided that a thread can only be executed on a CPU for not longer than 4 milliseconds is that Microsoft want to avoid then a specific thread hijack the CPU. So think about a very long running query. Maybe it runs for 5 minutes, yeah, which is not unusual, I would say. So when you allow SQL Server to execute the same thread, which is allocated to the same worker, to the same task, to the same request, which is the same query, for 5 minutes, every other query has to wait, right? Because again, so the thread or the CPU is hijacked by this request. And this is something which yield to complete imbalance. So therefore, Microsoft decided, and don't ask me why it is 4 milliseconds, because again, in former times it was 8 milliseconds, yeah, but I think they did a very, very detailed analysis in order to define the maximum, I would say the 4 milliseconds, which is a quantum. And that means once the query is executed on the CPU and it reaches the limit of 4 milliseconds, the thread have to leave the running state and has to go to the runnable queue. Because the other threads which are currently waiting in the queue now can be executed by the CPU. That means you have you have something like a balanced query execution over time. So the drawback for sure is that you have these kind of context switches. Because again, think about 4 milliseconds when the work is not done, all the instructions which you load into the cache are completely released because a new thread will, the CPU have to work on a new thread. So it will load all the instructions into the cache, will work on the task, and after 4 milliseconds, all these instructions will be flushed from the buffer again, which is for sure not a very effective mechanism. But again, it makes sure that you have something like a balanced query execution over all queries which are currently in your pipeline. So that is about the scheduler. We can get information about the scheduler by the, for sure, first of all, by the DMV. DMO is this info. So we can see the CPU count and the hyperthread ratio, and for sure then we know the number of physical cores. So I have 8 logical cores with a hyperthread ratio of 8 and 1 physical core. You can see the quantum in milliseconds is 4. Yeah, so you can see the quantum in this DMO's this info. And here we also see the maximum worker count. And again, the maximum worker count highly depends on the number of CPUs. Because it makes no sense, but you can do it if you want. and I have seen customers, they did it, they increased the maximum worker count. So for my machine, 576 is the maximum worker count, which makes sense for my machine. But there are some scenarios. Think about databases in an availability group. So when you have a database in your availability group, every database will already allocate, I don't know the formula, but if I remember correctly, it is something like 4 worker threads, just for being in an availability group, even if the database is not synchronizing. That means the more databases you have in your availability group, the more worker threads you already allocate, and they will never ever be released anymore. So think about a scenario where you have maybe 100 databases in your availability group, and consider, again, I do not know it by heart, that every database will allocate 4 threads. That means 400 worker threads are already allocated by just creating and operating the availability group. That means you have only 176 worker threads for my machine, which are available for query execution, which is next to nothing. In this case, it can make sense to increase the maximum worker count, because most of the time the worker count, the worker threads are more or less idle, right? It really depends on the workload on your availability group, but consider most of the time the threads are idle. Then it makes sense to increase the maximum worker count. But again, it is not a very good idea to increase the maximum worker count. I don't know, maybe double it or whatever, because you have a bottleneck in your CPU now. Think about the life cycle of a thread. When you have more worker counts, let's say you double the number to 1,000, 1,100, that means you have potentially 1,100 worker threads in your schedule, and every thread have to wait. And the bottleneck becomes your CPU, because every thread will be executed by the CPU for just not more than 4 milliseconds. That means the more worker threads you have in your schedule, the longer your queues will be. That means you run I would say, in a scheduler bottleneck. And that is something which you should prevent. And that is also the reason why the license, that you have to pay for CPU, is dependent on that model. There's nothing about memory. Everything is dependent on CPU. And that is the reason why. For sure, you can increase, but it is not a good idea, because you will see a lot of problems when you increase the maximum worker count, because you think you are smarter than Microsoft, right? So you also see that the current scheduler count is nothing like a one-to-one relationship between the CPUs, the logical cores, and the logical scheduler. That means for every core, I get 1 scheduler. We can see 10 more, but I do not want to cover this. But we have also a view which is available, DMOS schedulers, where you can see the schedulers. So I have 8 schedulers, and all of them have the status visible online. Why is this important? You know about the Affinity Mask. So the Affinity Mask is something which you can set here on the instance. We go to the properties, processors. This is the Affinity Mask. And you know that if I have more than 1 physical core, we will see more than 1 logical NUMA node here. But nevertheless, some customers assign a specific CPU to either IO affinity or to the processor affinity. And that sometimes makes sense when you run more than 1 service on the same machine, because you want to prevent that the CPU will have something like contention, right? So that means once you disable the CPU in the Affinity Mask, it becomes So SQL Server cannot use the logical core anymore, which is the logical schedule, nothing else. So that's, I would say, in a nutshell, everything you should know about the schedule. Let's go down, down, down. So the worker count or worker thread, I think I already explained. Here, by the way, is the formula. It depends whether we have less or more than 64 CPUs available, but you can see that it is highly dependent. So the maximum worker thread is highly dependent on the number of logical CPUs. And that is the license costs. Yeah. Okay, let's go down. So I can skip this. So the next thing I want to talk about is what is query execution time? So think about the following. A query executes for 10 minutes and it is done. The next time you execute the same query, you just run for 1 minute. So there is a difference, a big difference. So in order to understand what is going on and what is the reason that sometimes the query is running fast and sometimes the same query is running horrible slow, you should understand what is the elapsed time. So the elapsed time is nothing else than CPU time, which is n times 4 milliseconds, which is n times the quantum. Then we have the so-called signal wait time. So that is a time SQL Server or the thread have to wait in the runnable queue, because currently another thread is running on the CPU. And we have the wait time, the resource waiting time. This is the suspended queue. That means overall, the elapsed time is nothing else than wait time, which is suspended and runnable, plus running. So when you look into a query execution, we will do it in a minute, and you enable time, also statistics time on, you will see the CPU time and you will see the total execution time, which is nothing else than the elapsed time. That means when you subtract the CPU time from the total execution time, you know your signal or resource wait time. That is the time SQL Server have to wait. It is doing nothing. And when you see a query which is running sometimes very fast and sometimes very slow, you must compare the CPU time. Everything else is nothing you can directly impact by, I don't know, rewriting the query or whatever. In most of the cases, there is another reason that the current query is waiting for a specific resource which is currently allocated by another query or by another process. Again, think about a blocking situation. One query is executed and requires an exclusive lock. I don't know, update or whatever, or delete, whatever. And in the meanwhile, you execute a query which is, and you ask to read data which are currently in transition, because the transaction is not committed nor rollbacked. That means the shared lock is not compatible with the exclusive lock. And that is why the query which is trying to read the data have to wait until the insert, also the DML operation, is committed. The problem is not your select statement. The problem is your DML statement. And that is something you have to understand whenever you do performance tuning, especially query tuning. You have to identify the culprit, the reason that the query is running slow. Okay, let me go down. So there's one, I think, very famous and well-known DMV. It's not a DMV, it's more than a DMV, which you can get from Paul Rendell, so sqlskills.com. And it mainly depends on this DMO's wait stats. So again, the wait stats, let me do the following. This DMO is wait stats. We can see SQL Server 2019 have 1,080 different reasons that SQL Server or the query must wait, right? So these are all the reasons why SQL Server have to wait and cannot execute the work. So, and in order to figure out what are your main, I would say, main problems on your SQL Server, you should always, whenever you do performance tuning or whenever you do whatever you want to do in order to make SQL Server faster, the first thing is look into this DMOS, this info, in order to understand when the SQL Server was restarted last time. Yeah, because if you restarted the SQL Server 2 minutes ago, then all these kind of statistics are completely nonsense. Because if you only look in a time frame like 2 minutes, you cannot work with something like this. So this is something you have to understand. I would say at least 2, 3, or 4 days. Normally you should take into consideration that on weekend specific jobs are running on SQL Server. Yeah? So that means you should keep, I would say 4 or 5 days into consideration. So when you have something like this, so when SQL Server runs longer than 4 or 5 days, it is definitely worth to look into this DMOS wait stats. And again, so this is just another interpretation of this DMOS wait stats. We can see why SQL Server is currently, why SQL Server was waiting. Yeah? Because this is just, when I execute the same query another time, the total time is higher than before because it sums up over time. So currently, my machine, which was started an hour ago, yeah, was waiting on CX packet. You can see it here. Wait time in seconds. Then the second wait type. Yeah? So the second reason why SQL Server was waiting is Asynchronous Network Io. Then I have something like CE live target TFV and so forth. And this is the information you need to understand what you need to tune, because it definitely makes no sense to think about, I don't know, pagelet contention, yeah, because, or I don't know, yeah, pagelet contention is a good example because we only see page IO ledge contention in the first 10 wait scenarios, yeah. So therefore, it makes no sense to concentrate on something which is not listed in the first 10 of your list. So you can see that currently I should worry about CX packet. And now let's try to understand what we can do with a list. So let us focus on CX packet, because CX packet is by chance the first in my list. SQL Server wait for 220 seconds since SQL Server was restarted. What does it mean? So CX packet, and there is a description from Paul Rendell for every wait type. And you have to understand, and you must understand, what is the reason that CX packet becomes your most prominent wait type. So therefore, you have to understand what is CX packet. So CX packet is class exchange packet. That means whenever SQL Server is running queries in parallel, SQL Server just stops the time it takes for the query to be executed in parallel. So once the parallel execution started, the wait time starts. Once SQL Server stops parallelism, the wait time stops. So is this good or is this bad? It really depends. So CX packet, again, just tells you that a high number of queries are running in parallel. Is this good? Is this bad? I don't know. It depends. Do you have a data warehouse? Then I definitely assume that you will see a high number of CX packet because you are dealing with a high number of rows. So, and you know that column store indexes and batch mode and everything like this highly benefits from parallelism. In an OLTP system, I would say CX packet is something I wouldn't see in the first 10 of my wait time lists. Because think about the following. CX packet depends, or the parallelism depends on the cost threshold for parallelism. So once you set your cost threshold for parallelism on your instance, I would say nowadays maybe 30, 40, 50, I have seen 100. So SQL Server only considers parallelism once your expected estimated costs for the query are higher than your cost threshold for parallelism. That means when your cost threshold for parallelism is set to, let's assume it is 50, and you still see a high number of wait time by a CX packet, it just tells you that a lot of queries which you're running are even more expensive than 50. So that means in an OLTP system, where you normally deal with less number of records and you can rely, and you should rely on indexes, that already gives you an idea that you have a bad index strategy. The only way to reduce CX packet is to reduce the complexity of the query, to reduce the estimated subtree costs. Once the subtree costs are reduced and you are below 50 in our scenario, SQL Server will not run your queries in parallel anymore. It will run the query with just one thread. It depends. When you have a blocking operator, then you still have more than one thread, but at least CX packet is reduced. So why should I worry about CX packet in an OLTP system? The problem is the following. Think about that you have a CPU, 8 logical cores, yeah, and you do not limit the max stop, which means every query can allocate, in my scenario, 8 threads. So when you run your query with 8 threads, because it is running in parallel, and you run a lot of queries in parallel at the same time, you can only run 576 divided by 8 queries at the same time, because otherwise there is no idle thread available anymore. That means when there is no idle thread anymore and the task is waiting for an idle thread, you can see it here. Yeah? So the task is waiting for an idle thread. This is something which is called thread pool starvation. So the wait time you will see is thread pool. So that is the name of this scenario. So when you can see a high number of CX packet in combination with a high number, so a high wait time, yeah, by thread pool, then you know already that you do not have an idle thread available anymore, and the task have to wait in front of the schedule. That is the second escalation. So CX packet per definition is not bad. But when you see CX packet in combination with thread pool, then you know already that you have really a CPU issue. And then you have to reduce the cost threshold, the estimated cost by, I don't know, adding the meaningful indexes, or you should increase the maximum, the cost threshold for parallelism, and maybe reduce the max to be on an instance or database level. You can do it on a database level as well. So that is about CX packet. The next is Asynchronous Network Io. And again, we can go to all these information here, which are available in this view. Asynchronous Network Io is something you shouldn't worry about, because Asynchronous Network Io will tell you that SQL Server can produce rows or data much faster than the client can receive the data. So between SQL Server and the application, there is a buffer. And when SQL Server produces data, so think about you select 1 million records from a fact table or whatever, all these rows will be sent to this buffer. But the buffer has a specific size, so it is limited. So once the buffer is full, Asynchronous Network Io starts, and it will measure the time until it takes that the application will read all the information from this buffer. So SQL Server can produce more rows and send more rows or new rows to the buffer. Nothing you should worry about it. The only issue with Asynchronous Network Io is you should think about why is your application not fast enough? Yeah, why is SQL Server waiting to send rows to the application? Maybe this is a network problem with your network card or whatever, which is common, I would say. Or you just send millions of records to the client and you will filter the data in your application rather than on SQL Server. This is what I have seen often. So I don't know, think about an application where you have a list view and people just want to see all customers and they do not have, I think it's called pagination or something. I hope this is the right word, where you only ask for maybe the first 1,000 rows. And once you go to the next page, the next rows will be retrieved from SQL Server. You can do it with the offset, right? So that is a signal or an identification that your application, the code, is not very well written. So then we have live target.
There is a question.
Yeah. Sure.
Whether Async Network IO, is it only outbound or also inbound? Sorry.
It's only outbound. That means SQL Server will send data.
Yeah. Thanks.
Yeah. So okay, everything else here we can skip, but write log. Yeah, write log is something which I always see in the top. I would say at least top 20. Write log is definitely something you have to understand, and you already, hopefully you understand that. 1 second. First of all, I will open this picture here because it will tell you what is write log. So again, I'm not looking into a specific query. You can do it with Query Store in order to identify what are your top 20 queries, I don't know, by time, by CPU or whatever. I do not care about query at that point in time. I care about the right settings. I care about what is going on in the background, which you cannot see from a query perspective, because your query will never ever tell you that you have an Asynchronous Network Io issue. For sure, you can see all the weight information on a query level as well, but therefore you have to open the execution plan in order to get all the details, and you have to pick up the right query in order to see the weight stats, right? So the weight stat is a complete different approach, complete different perspective to look into your performance issues. So this is write log, and I know I maybe have 10 minutes or whatever. So yeah. This is definitely worth to understand. So, and again, I have seen a lot of instances, SQL Server instances, they suffer from write log issues. So consider the following. You start a transaction, either explicit with a begin transaction or implicit. That means SQL Server will start the transaction for you. So on the left-hand side, we will start our transaction. Let's consider we do a DML statement. I don't know, we will insert records. Yeah, insert records. So, or we will update records. Update, I think it is easier to understand. We will update records. So once SQL Server identifies all the pages, they have to be updated by the DML statement. SQL Server will look into the buffer cache, which is the memory part where all data pages, not all, but the buffer cache has a specific limit, but all the data pages SQL Server have read so far are located. So it will compare with the so-called hash map whether the page is in buffer or not. When the page is not in buffer, it will read the page from the physical I/O, from the physical file, which is a physical I/O, which is normally, I would say, the slowest operation on SQL Server, something you want to avoid. So then it will send the page into the buffer pool, the buffer cache. So every operation will happen in memory, never ever on your disk. Okay, so the page is in your buffer, and now the update will modify the page. That means your page becomes dirty, so-called dirty page. You can see it here, dirty page. And then there is an asynchronous process, which is called checkpoint, which runs depending on your recovery time. And it will flush all the dirty pages to your disk. This is an asynchronous process because it is horrible slow, right? SQL Server has some algorithms in order to make sure that it will be sent all the information in a, let's say, in an ordered fashion to the disk. But again, it is writing to this is definitely slow. So, but I would say the magic happens in your transaction log. Because think about the following: we start the transaction, and this process happens, and in the meanwhile, another process happens. So all the information, so I would say the log records, the former detail of the page, and all the details after the update, so the former build and the current build of the page after the DML operation, all the information are called transaction records. The transaction records will be sent to the so-called log buffer. The log buffer is also a memory part of SQL Server. So think about it. It is a transaction which is first of all sent to a buffer. Now let's think about a scenario where SQL Server crashes. So SQL Server has all the information, all the transaction logs in your log buffer. It is not yet hardened to disk, to the transaction log. So all the information, all the transactions are gone. They cannot be recovered because memory is something which will not survive a crash. So what does it mean for your transaction? Nothing, because your transaction didn't get any commitment or acknowledgement from SQL Server so far, because the information which are currently located and only live in the log buffer were not written to the transaction log. Only when the transaction log or the transaction records are sent to the transaction log, which is called write-ahead logic, then SQL Server get the acknowledgement that the transaction is committed. And the application get the information, the update was successfully done. So, and you can see this is also an asynchronous process. So we have a log buffer, which is, we have n log buffers. Every log buffer has 60 kilobytes. And either you commit your transaction and the transaction is less than 60 gigabyte, then you will send the information to your transaction log. Or when you have a transaction which is bigger than 60 gigabyte, that means you have n times n log buffers, then after every 60 kilobytes, the information will be sent to the transaction log. That is something where SQL Server tries to optimize and minimize the I/O request, so the write request to the transaction log. But now we can see a high number of write log. So SQL Server was waiting, I don't know, let me go back in my scenario. Okay, it is not that much, but believe me, do the same on your instance. You will see for sure much higher numbers, because again, this was only, I don't know, half an hour ago. But again, we will see a high number of write log. That means you will send, or this is the time it takes to flush the log buffer. So that means the slower your disk is, where your transaction log is located on, the longer it takes to flush the log buffer. And again, when the log buffer is cannot be flushed because maybe the disk is that slow. We have pending IOs, right? Or you can see it in the performance counter average disk queue length, for example. Then we have another problem because the log buffer, there is a signal that the log buffer has to be flushed, but the disk cannot handle it. That means the transaction cannot send data to the log buffer anymore because it is full. Therefore, when we see a log buffer wait time, this is the next escalation. This will definitely tell you that you have a big problem with your transaction log. Because again, the transaction log, the disk is not fast enough. That can be one reason of write log and log buffer. And there's another reason. Think about that you do an iteration. And this is what I have seen often. Because people, I don't know why, but they do not understand. Whenever they update, insert, delete records in a loop, this is, per definition, when you do not do anything else, an implicit transaction for every iteration. That means you will insert a record, you will commit. Again, the loop starts. You will start a transaction, begin a transaction, you will insert, you will commit, and so forth. That means when you now know that the log buffer has to be flushed once a commit happens, that means for every single update, for every single DML operation, SQL Server have to send all the transaction logs, which is much less than 60 kilobyte, to the transaction log. That means you have you really stress your transaction log, yeah, your controller. It is completely overloaded because the transaction have to be written in a sequence fashion. Therefore, the controller is really, really under high pressure. So how can we release this? We can easily begin the transaction, then we can loop, and in the end, we do an explicit commit or rollback, depending on whether it was successful or not. Let's assume it was successful. Then you will commit the entire loops, not just one loop, all iterations in one transaction. So therefore, the log buffer mechanism will optimize the write operations to the transaction log, which completely reduce write logs. This can be, I would say, one way to resolve write log and log buffer. And there's, I know that I'm running out of time, but there's one last thing you can try to implement if you think it makes sense. You know about the ACID rule, so ACID, the D, durability in the end. This is the standard of SQL Server. But what you can do is you can say you do not want to have durability in your transaction. That means SQL Server will always wait until the log buffer reaches this limit of 60 kilobyte, and only then it will write the transaction to the transaction log. And that is a way to reduce write log completely. So this is something which you can do since SQL Server 2017, I guess. And for sure the drawback is, sorry?
14. Delayed durability is since 2014.
14, okay. It's 14, okay, cool. Yeah, and when you have something like an ETL layer, a staging layer, where you always can ensure that you can reload the data every time, even SQL Server crashes, right? Then it is definitely worth to think about the mechanism, right, to avoid that SQL Server for every commit has to write the transaction to your transaction log, right? That is something which definitely works. I have done it for some customers. They had CDC in place for an Oracle database, and they whenever SQL Server crashes, they always have to synchronize the data with the underlying Oracle database in any case. So therefore, we decided to have delayed durability on. Yeah? Delayed durability is the property, the feature of the database which you can set, and they completely reduced a write log. It was so much faster. But again, you have to ensure that you can recover the data once SQL Server crashes. because there is no guarantee that the log buffer is flushed when SQL Server crashes. And therefore, you can lose all the data which you have in the log buffer at the moment SQL Server crashes. Yeah? This is about delayed durability. I think I'm done. So there's so more to cover with weight statistics. Yeah, it's definitely worth to understand why SQL Server is waiting and not just focusing on a specific query.
Great. Thank you very much.
Welcome.
This is time for questions. I put a link to about delayed durability in the chat if you're interested about that. And while you think about questions, I will also put here a link to the famous script you mentioned by Paul Rendell about weight statistics. So here is the link now. It's quite useful because it filters out all the weight types that are not really important.
Exactly. And this is not just the script, the entire website for SQL skills and really describes almost every, no, this is wrong, SQL Server, and then 1 second. It will describe every weight type you have. Yeah? And that's definitely very, very useful. I just want to open this one, library. Here, this is a library. And here you can search for a specific weight type. And I don't know, let's go to Asynchronous Network Io. And you can see, first of all, a graph. Yeah. So the occurrence and the percentage of instances experience weight type, in order to understand whether this is common or not common. Then you have the official online description, which is, I would say, almost, or not almost, but in most of the cases, not very useful or meaningful. And then you have a description from Paul Rendell and also the reasons why you are waiting on this specific weight type. And also ideas to resolve it.
Yeah, I put the link to that as well in the chat.
Yeah, great.
All right, any questions? Anyone? Feel free to write them in the chat or open your mic.
Yep, more than happy to answer.
Whatever. Mayor says, amazing lecture, thank you.
You're welcome, and sorry for the technical issues I had in the beginning, but I don't know what happens.
No problem. Well, looks like no questions. So thank you again, Thorsten. It was a great session.
Thanks a lot.
And thank you, everyone. We'll see you next time.
Thank you.
Bye-bye.
Bye-bye. Bye.
Yes, bye. Thank you.